being equal to 4. We increased the number of rectangles to 8 and we got a better approximation. When we increased the number of rectangles to 50, we got an even better approximation. When the number of rectangles n goes to 500, it's an even better approximation. So it stands to reason that if we continue to have more and more and more rectangles, so split that same subinterval up into more and more tinier and tinier subintervals, then our approximate area is going to get better and better. And it turns out that that is the case. And so for a continuous function f, we say that the area under f on the interval from a to b, in our case a to b was 0 to 1, the area under our function on that interval, well, that is approximately equal to the Riemann sum where we had right-hand corner rectangles and n subintervals, which is also approximately equal to if we did the same thing with left-hand rectangles. And if we allow the number of rectangles, that's this n right here, if we allow the number of rectangles to go and get really, really, really big, in other words, if we take a limit as n approaches infinity, then instead of having an approximate area, we get an equal area. And if I take the limit as n approaches infinity, and I'm using left-hand rectangles, I also get that exact same area. So we have approximations when the number of rectangles is 8 or 50 or 500 or 1,000 or 10,000, but if we allow n to go all the way to infinity, then we have an exact area. Okay, any questions about this? Okay, so, oh, go ahead.
It just seems like there'd always be some little amount that wouldn't be.
So here's how that works. That's okay. A very similar idea to as x gets closer to a fixed value of a, what is the y value getting closer to? It's that same little fudge factor in there. Okay. And the thing about the fudge factor is that we can make that fudge factor arbitrarily small. Right. So the same idea will happen here. Okay, so this is the idea we're going to be working with, and we're going to make this a little bit more symbolic in our second hour of class, but I want to stop here and give you a 10-minute break to process this and go outside and cool off a little, and I'll see you in 10 minutes.